Hello, I'm Ritchie. I'm a Doctoral Researcher Co-President for this academic year, and in the lead up to Earth Day we've been asking our Doctoral Researchers to submit a short 1-minute video of their environmentally themed research. We've then been posting those videos online for the last couple of weeks as part of a social media campaign to spotlight our environmental PGR researchers. First and foremost, a massive thank you to all those that submitted videos. They were all awesome, very clear and very informative. I learned a lot during this process, so thank you on a personal note for sharing that with me. We did this for two reasons. Firstly, we wanted to spotlight and promote our doctoral researchers who are engaging in such a crucial topic that it's worth spotlighting. And secondly, to highlight the breadth of environmental research going on at the university across the demarcations of schools, and learning from each other across schools is a key component of the future of our research culture. So once again, thank you to all the speakers that got involved, and thank you to those that liked and viewed the videos all along the campaign. Thank you.
Hi, I'm Tessa Driessen. I'm a fourth year PhD student at Geography and Environment at Loughborough University, and my PhD is about human impact on crater lakes in Western Uganda with a focus on the past 150 years. So what do I actually do? Well, I've already been a few times to Uganda, and then we visit these lakes and we drop a really big core to the bottom of the lake, and then the tube fills up with sediment, and the sediment we bring back to the UK here to this lab. And then I turn the sediment into slides, these slides, and they contain diatoms, which are single-celled algae and pollen grains. And then I spent months behind a microscope counting these diatoms and pollen, and eventually I get several graphs that look like this. And this indicates time, and this is the species composition, and this shows me the change in species composition over time. And this can indicate changes in past environments, and also how humans have actually impacted the lake and its surrounding area.
Hi, I'm Luke Jones. I'm a first-year PhD student at Loughborough University working with the Centre of Renewable Energy Systems Technology. My project is to develop an anti-soiling hydrophobic coating for solar panel cover glass. Now, in all environments around the world, from the usually rainy UK to the blistering hot Middle East and North Africa, we have a problem with solar panels known as soiling. Dirt, dust, and debris settle on top of the solar panel cover glass and stops the light from entering the solar panel to generate electricity. The solution, which is my project, is to develop an anti-stick hydrophobic coating to the surface of these cover glass. If you apply this coating, you get two benefits from it. One, you stop that dirt, dust, and debris from sitting on top of the surface, improving the efficiency of the solar panel. And two, it becomes a lot more cost-effective in its lifetime, meaning that more industry should take notice of this technology and apply it in the future.
Hi there, my name is Melissa Schiele and I am a PhD researcher in the Wolfson School of Engineering. I'm also a marine ecologist and I work with the Zoological Society of London. My research is all around designing, building and piloting fixed-wing drones in marine protected areas and other areas of fisheries. And the purpose of these drones is that they are used for monitoring of illegal fisheries, wildlife and also plastics. And the cool thing about them is that they actually land on the water, which means that they are really easy to use in areas where there isn't much land to land on, for example, tiny tropical islands. My research takes me all around the world and I'm just about to head off to the Maldives soon for 3 months. So yeah, if you want to find out more, you can find me on my Twitter, explorer_mel.
Timo Kelder from Loughborough University, and in my PhD I study climate extremes. In particular, I use weather and climate models to understand the likelihood of extreme events. For example, recent events in the UK, such as floods and heat waves, have been quite severe, but how severe could they become? In my PhD I study how we can use these climate models to understand their likelihood of occurrence, which can then inform decision making to better prepare for future events.
My name is Festus, and the topic of my research is waste as material for visual practices. A waste we know constitutes materials that are discarded. In the developing countries like Nigeria, waste represents an issue which unfortunately has not been given its rightful importance. So the research investigates waste items like polystyrene, plastic, cyber paper, toilet paper, receipt, cartons, and newspaper as pigment for contemporary construction. So research questions include: can waste objects be reused to alleviate the shortage of art material in Nigeria? To what extent can artwork campaign against the careless disposal of waste in Lagos, Nigeria? So the practice-led research shall engage the potential of notch theory and gradient theory to inspire a reduction of pollution of waste in the environment by using the constructed work as exhibit of campaign for the use of waste and discard in identified environment. Thank you.
Hello everyone, my name is Gustav Nanujkar. I am a last year PhD student at Crest in Loughborough University. I am working on the development of a medium temperature solar thermal collector. So this is the collector I am working on. The novelty of this collector, it combines the design feature from a flat plate collector and concentrator. This is a compound parabolic concentrator which accepts a diffuse as well as beam sunlight, and it can be used from medium to high temperature applications. It can be integrated in building facades, outer structure of the building, as well as it can be used in industrial process heat applications where the temperature requirement is from 150 to 200 degrees Celsius. Based on the simulation results, this collector is very efficient, and in the temperature requirement of 150 to 170, it can go up to the efficiency of 80 to 85%. Thank you very much.
Hi, my name is Jose Henriques and I'm an academic visitor in the School of Architecture, Building and Civil Engineering at Loughborough University. I'm here with Mila, representing the Adaptable Futures Group, which is an international research group based here at Loughborough. Our work focuses on the design, construction and management of a more adaptable built environment, looking at the complex web of dependencies that induce, hinder and accommodate change.
Hi, my name is Mila. I'm also a researcher in the Adaptable Futures Group. We are now developing a research named Designing for Adaptability and Sustainability in Architecture, Between Bonds and Tensions. Our objective is to explore adaptability and sustainability, emphasizing their correlative and supporting benefits, while also identifying barriers of mutually adopting their strategies and solutions in architectural practice. We aim to find results to help in raising the capacity of a building to respond to changing requirements, considering both future and performance. For more information, don't hesitate to contact.
My name is Pawel Nycz. I'm a third-year PhD student at Crest, part of Loughborough University, and I work in a field of energy storage systems and its cooperation with Stirling engine and sodium heat pipes. During my 3-year program, I have built 2 testing stations. First one is for Stirling engines, including electrical heating system, water cooling loop, and data collection. The second one is for sodium heat pipes testing, that allows to test all parameters of the sodium heat pipes in a range of temperatures up to 750 centigrades.
Hi all, my name is Jay and I'm a doctoral researcher here at Loughborough. The topic of my research regards the reduction of CO2 in the construction industry through reduced consumption of concrete. There's a stigma around concrete being so bad for the environment, however this is circumstantial. Concrete production per tonne doesn't necessarily emit so much CO2, it's more the fact that last year 4 billion tonnes of concrete was consumed worldwide, making it the second most consumed item in the world after water. So how can this be reduced? Well, I believe feasible adoption of topology optimization in the construction industry could contribute to this by only distributing concrete through an element where it is needed. I believe that up to 50% reductions in raw materials could be achieved, and similar figures for the reduction of CO2.
Hey all, my name is Liam and I'm a second year doctoral researcher here at Loughborough University. The focus of my research covers the application of ultrasound to electric vehicle batteries. This is to enhance the ion transfer rate inside the cells, which will aim to improve the performance, longevity and health of lithium-ion batteries. With regards to the environment, this will decrease the degradation rate of the battery and allow for the cells to be in use for longer. Therefore, this will lessen the demand on production of more batteries and requirement for mining and extraction of the exotic materials that come from these. Furthermore, this will also lower the amount of waste or end-of-life batteries entering landfills. This will therefore also give industry more time to investigate and invest in electric vehicle battery recycling and second life applications. To finish off, this research will help bring about extreme fast charging of electric vehicles and allow for the full charging of cars, adding 200 miles of range in about 10 minutes. Thank you.
Everyone, my name is Hamza and I'm a doctoral researcher at Loughborough University. The title of my project is Dynamic Refinement and Energy Efficiency of Electric Powertrains, and I'm looking to improve our understanding of the noise, vibration and harshness issues in the powertrains of electric cars. Now, this is very important from an environmental point of view because a more energy efficient car would mean less use of overall energy to charge its batteries, and we can increase the lifespan of electric cars by reducing the unwanted vibrations, because obviously these vibrations cause damage to the car, and obviously if we can reduce the mechanical noise from the different components of electric cars, it will reduce noise.